Good morning. My name is Vishnuvardhan. I am from Electrical and Electronic Department. And my today's network analysis tech talk topic is analysis of a novel active filters for balancing and recreate power compensation. So the growth of electricity supply industry and inequity in general transition and distribution system has affected quality of power. Uncompensated reactive power and unbalanced load lead to poor and distorted voltage profile. The severity of loads causing reactive power and load unbalancing has been recognized long ago, and many attempts are made to define, study, and derive the methods for load balancing and reactive power compensation. Conventionally, lossless reactive components were used for load balancing and to improve degraded power factor. Limitations of compensation in two steps and introduction of harmonious and switching surges in the AC system restricted their use significantly and forced the power electronic expert to design schemes with dynamic and adjustable level of compensation. Many control concepts like scenario detection, half and full integration method by Bagos, instantaneous reactive power theory by Akaji, etc. Negative negative sequence component control theory by Bharadwaja, and use of lossless reserve control reactive elements by Sadek and Karen at A1 E88 has been reported for load balancing and power factor correction, but all these control ideas have been their own limitations. So accuracy of Simorian detection method depends on the attenuation characteristics of low pass filter. Large the attenuation, better filter, but large time delay. Half and full integration method response slightly action takes place in half cycle or dual cycle of supply respectively. Theory of inject of negative and current into the system using inductive energy storage elements has its inherent disadvantages. At this paper is to compensate quickly, continuously varying unbalanced lagging power load. A little phase IGBT based PWM voltage source inverts with DC bus capacitor is employed as compensator. Reference source currents are estimated by using DC bus voltage of the AF and balanced source voltage. A high T resist based carrierless PWM current control technique is used over source current. The output of the high hysteresis controller is fed to the switching devices of the VSI. In response to this gating signal, AF impresses three-phase PWM voltages to meet reactive power compensations of load currents locally. The proposed the proposed compensator explains the validation of a new approach for the reactive power compensation and load balancing and may effectively be used in electric distribution system. Excellent performance of the compensator is observed and it balances unbalanced loads and improves the power factor of the source to unity under continuous various load conditions. So let's see what is system configuration control scheme. Basic current configuration has been shown in figure 1. The proposed AF consists of three-phase IGBT based voltage source inverter with the DC bus capacitor as energy storage element. Load may be single phase, two phase, three phase, linear balancer or balancer leading, lagging or unity power factor. So the AF is connected in shed with load. Figure 2 shows the control scheme used. Reference peak magnitude of supply current is estimated by employing PI control over the reference and the bus voltage of the AF capacitor. The instantaneous reference source currents are combined to the peak value and unit current templates. The I isosteric rule based carries the current controller is employed over the reference source current and acts and currents to result in the gating signals to device of the AF. AI hysteresis carrierless PWM current control over supply currents eliminates the need of sensing the three-phase load current for reference current generation. Source currents feed only fundamental active components of load current and a small active power components of current to meet the switching losses leakage current in the DC bus capacitors and to maintain DC bus voltage to a constant value. The simple PI control over DC bus voltage of AF is used for the closed loop control of the DC bus voltage of AF. Modeling and simulation. The proposed system consists of an AF unbalanced lagging power factor, linear load, and three-phase three-wire AC mains. All the components of the system are modeled to simulate the transient and steady-state behavior of AF system. The operation of the control the operation of the control scheme is discussed in previous section. In this section, modeling equations are developed and analyzed in sequence. Estimation of peak value of supply current. Peak value of reference supply current is estimated using PI controller over the bus voltage of the AF. The DC bus voltage is averaged and is compared with its reference value. The resulting value error at the nth sampling instant is expressed as the output of the PI controller. The output of the PI controller V naught of n and the nth sampling instant is expressed as their VI where 7 and K are proportionally an integrate constant of the voltage controller. The output gain of the voltage controller is taken as amplitude of the source current. Estimate of instantaneous reference supply current. The unity power balanced three-phase AC supply current are estimated using the current templates. Unit current templates could be derived as the following. So these are the pictures with figure 1 which tells about the fundamental building blocks of a proposed AF, and this is the control scheme. So the AI so the AF the AF has demonstrated its capability of reactive power and load balancing in three-phase, three-wire electric supply system. PI voltage controller over the DC bus voltage of AF has improved the dynamic response of the AF and regulated the DC bus voltage to constant value. AF improves system efficiency because it avoids the reactive power and unbalanced loading of the distribution equipment and AC. Major advantages of PI controller can be concluded as simplicity, reference source current generation, requires sensing of only source voltage and DC bus voltage of AF theory, easy practical implementation, fast response, control action takes place in 1/6 time period of the supply, therefore responds satisfactorily to continuously varying loads. Important application of such type of AF would be the traction, light welding, heating, commercial building, air conditioning, domestic industries. Thank you.